Hey everyone, welcome back to the second version of our project IDGuard. So now this app opens up with the split screen authentication interface. On the left we have the IDGuard branding panel and on the right the login form. Now we support two authentication flows, one the Google OAuth 2.0 and traditional email password via Firebase authentication. The auth state is managed client-side with a React context provider that wraps the entire application, persisting sessions across page reloads. Now, clicking on with the Google trigger, it triggers the Firebase's sign-in with pop-up flow using the Google Auth provider. On the successful authentication, the user object containing the UID, display name, and the email is stored in the context and we are redirected to the dashboard. However, for the new users, the Create Account toggle reveals a registration form with name, email, and password fields. Firebase handles password hashing and token management, and we never store the credentials locally. Now we are in the dashboard. This is the teacher's command center. At the top, the four animated statistic cards show the total classes, total students, average attendance, and total session, each with a flip animation on mount. These are computed in real time from the Firestore documents. Below that, the attendance trends line built with the recharts plots the attendance percentage over time across all classes. Each data point represents basically uh, a session, a date, and hovering reveals the exact percentage via a tooltip. The data is aggregated from the attendance record array embedded in each class document. Now, we also have the student at risk panel at the right side of the chart. It flags any student with attendance below 75%. Each card shows the student's name, class, SRN, and a color coded badge, red if below 50%, amber if the attendance is between 15 and 75. The count badge at the top gives an immediate sense of how many students need attendance. Now, we also have the recent session tab and the class performance tab. Now, the recent session shows the last 5 attendance sessions with date, class name, present count, and percentage. And it also shows the class performance ranks each by overall attendance, green for 80% plus, amber for 60% plus, and red below 60%. At the bottom, the class grid. At the bottom, we have the class grid. Each card displays the class name, subject, the student count, and also we can view this we can view the students and mark attendance. It jumps directly into their respective pages. We can also edit and we can also delete an existing class. Now let me click on the view student page. Navigating into a class, we see two column layout. On the left, we have the attendance calendar with month navigation. Each day cell is color coded by attendance percentage. Green for high attendance, red for low, and yellow for moderate. We can see that when I highlight on the yellow day, we can see the number of students who are present and the absentees as well. On the right, the student grid searchable by name, as you can see, and each student card shows a circular photo of the student and action buttons for editing, deleting, or viewing their analytics. Now we also have the student profile button on this version. This opens the per student analytics page, a dedicated profile view. At the top, the student's name, their followed SRN, and their parents' email. And on the right, we have their overall attendance. And we can also see if their attendance is below the 75% threshold, more or moderate. We can also see the total sessions attended by the students, class attended, and their current streak, and how long their streak was been held for. We can also see their monthly attendance trends and also the weekly attendance of the students and the recent attendance of their classes. We can also see the full attendance history of the student as well. Now, going back to the class page, we have a new feature on this update. It is called the bulk enrollment. The bulk enrollment model, a 3-step workflow designed for onboarding an entire classroom at once. So the step 1 is to upload, or we can drag and drop the Excel files or the CSV files. So this file contains the student data, columns for name, SRN, and optionally the parent email. The parser handles case-insensitive headers and flexible column matching. The second zone accepts the student's photo where each file must be named by SRN. For example, R25EF303.jpg. Now let me add the example student images that we have. Now when we click parse and preview, the system parses the spreadsheet across the reference photo file names against the SRNs. A preview table shows each student with their matched photo, name, SRN, and parent Gmail. Green means matched, confirming the photo associations. Orange means missing badges, and it highlights student without a photo match. Now when we click enroll, it triggers a sequential processing. Each student's photo is uploaded to the Firebase storage via the backend's admin SDK. This bypasses client-side security rules entirely. The backend generates a Firebase compatible download URL with a UUID token. Then the student record is returned to the Firestore class document. A real-time progress indicator shows the status of each student uploading, enrolled, or failed. In this case, all 3 of our students have been enrolled. We can go ahead and click the done button. Now let's move on to the mark attendance button. Now you can see this is the core feature. The page is split. The page is split between the webcam and the student grid on the right. Now, since all the 9 students have been there and all the 9 students have already been existing in our database, we can go ahead and scan all the faces at once. But if we are adding new students at once, what we need to do is, once the new students are added, we need to train the models so the model can learn new patterns of the face. So before scanning, the system must train, and the train model sends a request to the Fast API backend. The backend fetches all student records from Firestore, downloads each student's photo concurrently using async gather. It processes the images, it does the RGB conversion, downscaling if over 1600 pixel, and contrast limited adaptive histogram equalization for lighting and normalization. It extracts 128 dimensional face encodings using the face recognition library backed by dlib CNN based face detector. It stores the embedding in a Firestore sub collection at classes. The training status indicator turns green once the model is ready, as highlighted here. Now we also have the next feature, which is called the batch scan. It is a single webcam frame is captured and sent to the recognized batch endpoint. The backend basically decodes the base64 image, it detects all faces in the frame using dlib CNN detector. It extracts encoding for each detected face, compares each encoding against the stored embeddings using Euclidean distance minus confidence, which is 1 minus the distance, matches faces to the student using a threshold of 0.55 with duplicate prevention, and no student can match twice in a frame. Now let me do the batch scan, and since I'm the only one person present here, it has marked me present, and it can see that it has marked it has marked all the faces correctly, and it has matched with our database. Since no unknown faces are here, the unknown counter shows that it's 0. Now we can now let's assume the face recognition model failed, and we can also manually mark the students present in case the model fails. Now we can go ahead and click the save attendance button. Saving triggers a Firestore transaction via the mark attendance batch endpoint. The backend atomically updates the attendance record for today's date, preventing race conditions if multiple saves happen concurrently. If parent emails or phone numbers are on the file, the system sends, basically this is the parent's email and phone numbers. So the system sends the WhatsApp notification and email notification via Resend and Twilio APIs. Now let's move on to the reports page. The report page provides a filter panel, class selector dropdown, start date, end date, and a generate button. Now let's select a class and let's generate a report. Now, the system fetches the class data from Firestore and computes statistics within the selected date range. For summary, the card appears total sessions, average attendance, best attendance, and the lowest attendance date. Below that, a session summary table which shows each row is one attendance session showing date, total students, present count, absent count, and attendance rate with a color coded badge. Further down, a student performance table which shows a student's total session, present/absent breakdown, and overall attendance percentage. This table helps identify individual patterns. Now, let's click export as CSV. Now, we can see that the attendance which was recorded for the past time frame has been here in a spreadsheet format. The system generates the formatted XLS or CSV file using Sheet.js library, complete with headers, data, rows, and proper column formatting. We also have an Excel export option where files are named using the Excel pattern. Now, for the final now for the final summary, let's have an overview of the tech stack. We are using the front end Next.js 15. For the front end, we are using the Next.js 15, React 19, TypeScript, Tailwind CSS version 4, Framer Motion. For the back end, we are using Python's Fast API, UVCon with Hot Reload. We are also using the face recognition CNN library with 128 dimensional face encodings, Euclidean distance matching. And for the database, we are using the Cloud Firestore with document embedded arrays, transactional batch writes, storage. We are using Firebase storage, admin SDKs, uploads, token based download URLs, etc. Now for the auth, we are using Firebase authentication, Google OAuth 2.0, email, and password. Now for the notifications, we are using Resend for the email part, and we are using Twilio for the WhatsApp. Now for the charts and the other trend lines, we are using Recharts, which has the line, bar, stack bar, and etc. charts. Now for the exporting the final spreadsheets and sheets, we are using Sheet.js / XLSX CSV plus Excel. We are also using PWA Next PWA with cache first strategy for storage assets. The system is designed as a monorepo with separate front-end and back-end services. It is deployable to Firebase hosting and cloud run respectively. This was a brief demo of our project. I really hope you guys liked it, and I wish you a good rest of your day. Thank you.